For example number 2, instead of giving you a random point on the graph, we are now having a point at the origin. Origin as in 0, 0. And I want to create a line that will give us the shortest distance from the origin to the line here. Well, this line doesn't give us the slope and the y-intercept just yet, but if I can rearrange the term and rewrite it in slope-intercept form, I will end up with 1/2 for the slope and 4 for the y-intercept. 1, 2, 3, 4. Here is the y-intercept. And we have slope equals 1/2. Rise by 1, run by 2. So starting from this point on the y-axis, up by 1, run by 2. Here is another point. Doing the same thing again, rise by 1, run by 2. I'm seeing another point here. This line is represented by the equation x minus 2y equals -8. And I want to find the shortest distance from the origin to the line here, which once again involves a perpendicular line. And the equation for this perpendicular line can be obtained by starting with the slope of this line. Here is the perpendicular line. I need the slope of this line. I see the y-intercept. The y-intercept is 0. Pretty obvious. But I want the slope. And seeing how we have this line having a slope of 1/2, the slope for the blue line would give us negative reciprocal of what we saw from the red line. Once again, we have the y-intercept. This line passed through the origin, which gives us the y-intercept at 0. The equation for this line using slope-intercept form, y equals mx plus b, would give us y equals -2x. And using the 2 equation here, we can now find the point where they intersect by solving the system of equations. The point where they intersect can now be calculated by having these 2 equations bring together. Y equals -2x on one side and y equals 1/2 of x plus 4 on the other side. And I can now solve for x. The 1/2 here, technically, we have 0.5x. Group the x together and solve for x. We have 4 divided by -0.25. So let me do the calculation here. Four divided by -2.5. That gives us -1.6. And with x equals -1.6, I can now calculate the y coordinate of this point here by making a substitution. -1.6 for x. Bring it into the equation. We have y equals -2 times x. And that will give us 3.2. 2 times 1.6. So here is the coordinate, negative 1.6, positive 3.2. And if you were to do it on a graph paper, this point thus corresponds to what we are seeing here. If I have negative 1 here and negative 2 there, this point is approximately negative 1.6. And here we do have approximately 3.2 for the y coordinate. And if I want to calculate the distance from here to there, if I want to calculate the distance between these 2 points, 0, 0, and negative 1.6, 3.2, I can now calculate the distance. Yes? So all of a sudden figure out that it is actually easier than you think. So 1.6 for the x coordinate, difference of the x coordinate, and then difference of the y coordinate, 0 and 3.2, and this one 0 and negative 1.6, using the difference between the x and y coordinate. Set it up using the distance formula, and on my calculator, let me put it here this time, I have the square root of 1.6 square plus 3.2 square. And this will give us 3.58 for the distance. And that's the shortest distance from the origin to the line.